Good afternoon. My name is Mark Hubbs. I'd like to do a brief overview on our AMATROL model MT5 electronic motor control. Pardon me. Purpose of this hardware is to teach the fundamentals of electrical motor control, including introduction to motor control, manual motor control, overload protection, control transformers, control ladder logic, relays and motor starters, reversing control, automatic input devices, basic timer, and counters. And that's on a base system. This is pretty expandable or scalable, as you see, just the basic system to teach those 10 areas. And we provide the curriculum, what we call the LAP format previously, traditionally, but we have since migrated to a multimedia format. Makes the content, same content in terms of the delivery of the technology. Format's a little bit different. We do it in a interactive multimedia format using a lot of techniques to engage the learner, as well as graphics, interaction, and even a virtual format of the representation of the equipment behind me in a virtual format. So just to illustrate the amount of content just in the base system itself, some 8 modules in total, then expandable to everything from braking, reduced voltage, sensors, electronic counters, DC drives with SCR speed control, frequency drives, and even PLC control. So in addition to the student material, there's an installation guide that comes with the system to illustrate bills of material, basic startup sheets for commissioning and installation, any types of spares or maintenance that may be required, and checklists to make sure everything's there. That's typically part of the installation and commissioning. The third component in terms of didactic material is what we call the instructor's guide. So this guide here includes all the material needed for the teacher. Includes things like any data sheets that may be required, authentic assessment. So we, in terms of the cognitive assessment, we can test the knowledge about the theory and the technology behind me. But then the show me part, or the authentic assessment, is, okay, we're going to learn about reversing motor control. Show me how that circuit works. Any type of safety associated with this, all the test questions and answers, excuse me, all included. And part of the design and the evolution of this structure was a drive of technology some years ago down to lower levels in education. Typically, technologies delivered by a subject matter expert, SME, that generally has a good, profound knowledge of the technology. As that technology was pushed to lower levels, sometimes there weren't experts around that could know how the system operated. They would have to create their own material, and that's kind of how the learning system approach took root. One of the things in regards to the hardware that you're going to notice, safety is at the forefront of everything we do. So there is a lockable disconnect, and you'll notice that it's turned 90 degrees away from the user, and that's in prevention of any arc flash. The different modules you see, they're, bring it forward just a bit. So there's a grounding connection here, but you can see it's pretty modular, depending on what course or experiment we're conducting ourselves in. So we can build the different circuits using these modules. And you'll notice too on the backside, there's room for storage if other options were to be present. Another feature that I'd like to share with you, one of two ways this can be done. We have a manual fault module that can be utilized. We also have an option for a computer-based module. And this blue box, or black box, if you will, is basically, it's a collection of relays that's going to interrupt the different circuits so that we can simulate a fault where it's blind to the student. It can be tracked in the software by the instructor. We can track in a practice mode, in a test mode for faults. We can, the teacher then can track the time the student takes to resolve the fault, to find it, how many attempts to find the fault. It can be tracked that way. And lastly,